My name is Nirmal. I work for Bosch, and the talk today is Goodbye Red. So during the speaker pitch, I'm not sure if all of you were there, during the speaker pitch, I made a promise at that time that I'm going to tell you a secret. Yeah. So this secret was with me, or with my team for some time, and now it's 1 year, so I think it's time to just reveal it to the community to make sure that you also can utilize from that and try to see if it works for you. So it's all about, the secret is all about how we rescued a project. So this project was all red. So all red means we had all tests red, or most of the tests red. We had our integration tests or integration builds or nightly builds also mostly red. Yeah, and then we did some steps beginning of this year which completely turned the tide around, and magically it all became green. So I'm going to summarize all the steps that we did in this 1 year. Maybe some of these things are too obvious for you, but the message here would be that how did we put even these obvious things in a systematic way and got some success out of it. Yeah? So maybe a short background on what we do. So we at Bosch, or the division that I work for at Bosch, we develop automotive software, right? And as you know, that most of the modern cars has a lot of software running behind it, yeah? And it's all controlled using electronic control units. And the division I work for basically develops automotive software, embedded software, but the group I work for don't directly write embedded software. We develop software tools based on Java Eclipse, which helps these embedded developers make their products or deliver their products. So tools like modeling tools or code generation tools based on models or validation tools. Yeah. So this is what we deliver. So the project I'm going to talk about is basically this one. Yeah. And talking about tools, when I say tools, I mean this IDE or all these tools what we developed for Bosch. We really faced a kind of an evolution, or rather a revolution in the last 10 years with respect to the tools that we were building and using. And let's say a decade ago, we really had small tools like maybe built in C++ or something, or even Perl scripts. They were all somehow put together using some batch script, and they were all delivering or making products, and we were also delivering software, yeah, and quality software. And at that time, we had really small teams, yeah, sitting somewhere around the world, all developing different tools, heterogeneous tools, and all putting it all together to make a magical product. And the infrastructure what we had was also really small at that time. Yeah, no integration build servers or no nightly builds happening. It was all just compiled, build, put in some share, and deployed. And that was the infrastructure that we had. But things changed, yeah. The complexity of embedded software changed, and the complexity also came into the tooling world for us. And then we had to think differently. I cannot just go on like that. So that's the time when Eclipse came in, yeah, Eclipse 2.0 or Eclipse 3.0. And then we, at Bosch, evaluated what could be the next generation platform for us to make our tooling. And then we embraced Eclipse. Yeah, so, and we decided to go away from all our small heterogeneous tools, put all of them together, or redevelop all of them together as Eclipse plugins, and deliver one single IDE, right? So then all these small tools were put together into an Eclipse IDE as a product, and there were all the teams working differently, separately, now came together, working for this single IDE, right? And in the end, we now have, for example, 12 teams working for this single product from different parts of the world, 250 plus developers, or committers as we call it, for our product, and 500,000 lines of code already written, 24 integration servers running on hourly basis, on nightly basis, and all to make 2 releases in a year, and also 2 service releases. So that's what we do in 1 year. And we serve like 4,000 plus users with this IDE around the world. And it all looks simple in the beginning. Yeah, it was all good with Eclipse. You can develop plugins, and put it all together. It all works together. But what resulted was, I would say, in the end of it, chaos. Yeah, there were a lot of integration problems, And mainly what we saw was red after that. That means tests were red, our bills were red, developers were red, and the dangerous people, the managers, they were also red. Yeah? And then we thought it's time to stop this. Yeah? It can't go on like this, red for everything. So we just said, stop. Let's do something differently. So that was the beginning of this year, when we sat together and thought, what can we do? And we found 5 steps. What can be done? I just quickly go through the 5 steps and then go into the detail of each of these steps. The first one, we realized that we need to get the people on board, the right people on board. And then we need a mindset change. If something is red, it cannot be red forever, so you need a change in the mindset. And you need to also engage quality tools when you want to deliver quality products. You also need to track your quality continuously, so we might have to develop tools which tracks your quality, generates metrics for you. So we had to engage a lot of quality tools. And we had to change the techniques what we were following with respect to our test strategies. So we rolled out completely new strategies on how to work with our tests. And the last one was to set the limits. So it's not enough you roll out some policies, you also have to define some limits for it and set some limits and also define some consequences. What happens if you don't meet these limits? So that was the 5 simple steps what we did. Yeah? And starting with the first one, getting people on the board. So the first set of people we got on board were these dangerous people, managers. Yeah? So, and how do you get these people on board? Just show them numbers. Yeah? They believe in numbers, so you have to get the numbers for them. And I'm sure most of the projects have some kind of a logging of the effort that goes into a project, what's the effort that goes into development, how much of effort goes into testing or rework or bug fixing. You just need to put all these together in a way, and you will be surprised to see in such a situation that how much of effort is going in all this rework and bug fixing rather than on the development activities what you should be doing actually. And that was enough for us to convince our managers. And the second set of people you need to convince or get on the board are the real users. For us, the users were paying us, so we had to have them because they are paying the money for us to do all this development. And how do you convince these users? What we did was we established something called like change control boards. Maybe you have such boards already in your projects. Maybe they're not called change control boards. So a change control board was a group of stakeholders where you sit together and you prioritize what you need to do for a release. Yeah? And in these change control boards or these prioritization meetings, you just show them the numbers again. Yeah? Maybe in a different view, not the manager's view, but it's the user's view. And then you need the commitment from them. This is the first and foremost thing that you need to do. You need to have the commitment, otherwise you're not going to come forward with your activities. So that was the first step. And the second step, what we did was to address the mindset of developers themselves. So the situation in the project over the time was like this. Everyone had a mindset that it works for me. I can compile my code, I can build my code, can deploy it, it works. My tests are green. I don't care if the product is not built on a nightly basis. I don't care. As long as my code is working, it's fine. And that was the mindset that we had to address first. And the other mindset we had was, if the build is red, somebody's going to fix it. I don't have to care about that, right? And there was other set of people who thought, if I have to do something about the build, somebody's going to come and tell me. Somebody's going to write a mail. Yeah. So until then, I don't do anything. We had all these types of people. I'm sure you would also find such people everywhere. And there was the last set of people who said, it's anyways red. It's never going to change. I've seen it over a while. If it's green, I'm surprised. But red is pretty normal for us. Just go on like that. And then we introduced something called the Yellow Book. So Bosch, being a big organization, pretty much like other big organizations, we had a lot of quality process and documents written which only the process guys read and understand. Nobody else understood what they meant by it. Yeah? It's all towards quality, but nobody can really read them and understand them. So we introduced something called the Yellow Book, what was not really just another process document. It was not really a Bible, so to say, which says that if you don't follow it, you will be punished or something like that. So it was really simple English, and it was a set of best practices for the developers, what's expected of a developer on a daily basis from the first sip of coffee that you take to the time that you leave your office. So it's really simple English, what you can follow and then make the working environment, your system, such a stable one. It was mostly the Yellow Book was for something like, you say, oh, so what? To something like, oh my God, what? The build is red today? Or something like, oh, the bridge is falling. That was the change that we wanted from this so what to the what. Yeah, that was what we wanted to change with this Yellow Book what we had. And it looks something like this. It was a single sheet of A4 paper, printed, laminated. It was on everyone's workplace. And it basically said the instructions starting from the builds and what do you do, how do you react to a build in all plain English. And the message that the Yellow Book passed was, if you caused a test to fail, if you caused a build to fail, you have to fix it. There's no other go. It's you. You have to do it. And if you didn't cause it, just check if someone else is fixing it. It's not enough that your code is green today, and so you don't do anything about the red build. You go and check if is somebody already working on that, fixing that red build. And even if that's not the case, what you do is you try to tell somebody to fix it. Just 3 simple steps, right? And that's really made a difference for us. Following these 3 simple steps of you fixing your own problems, trying to inform people about the problems, and try to find the right people who can fix these problems. The next step what we did was to engage these quality tools, what I said. So we also developed a lot of in-house tools, like some performance measurement tools, which continuously tracks the performance of some of the use cases on a nightly basis and reports if there is a problem. So this is what I mean by quality tools. And we also purchased a commercial tool. So this is a commercial tool, so I don't want to market this tool, but I just want to say that this Sonar Cube really helped us because it was a dashboard for us where we could see the state of all our builds, the state of all our tests, the code coverage that we have. And Sonar was also doing a lot of static analysis of the code and reporting like blocker issues or critical issues which could be potential bugs later. Yeah. So we had a good view on where we stand with respect to quality and how much of backlogs we have with respect to quality. So that's the only tool we really purchased, and it's really helped us. And I go to the next step of adopting new techniques. So this was a very important step that we had to do to change the way we look at things. The first step that we did was to set up a build lamp. Yeah, I think many of you guys know it. You're all nodding your head. So before we had a build lamp, we had to basically log into a server, your build server, and see what's the status of your component. But once we had a build lamp on the floor, you come into the office, and the first thing you see is either a green or a red build. Or if it is building, you see it in a different color. And this was one of the turning points for us to see the status of the build. When you turn around, you always see the status of your build, and then you have always a motivation to bring it back to green and not let it remain red for a long time. The next thing that we did was also to set up an info board or an info screen in your kiosk area where you often go to drink your coffee. And this info screen showed us a lot of details of different components, like what's the graph of the tests, how much was the test success over the last 1 month or 2 months, and you could always compare yourself and maybe also with others, yeah, where do you stand with respect to quality. And this was the info screen board. It just costed an LCD screen and some metrics, what was already there on the server that was just beamed onto it. And then the most important thing was that we re-strategized our test process. This was really a problematic area for us because having such a big system, we had very less tests because it was just developed over the years in that way that we either used to do manual testing, so it's a GUI-based application, so we were always doing manual tests, or there were also some GUI tests written, for example, with SWG board or window tester, and these tests were never stable. You change something to your UI, the test crashes. Yeah? So we have completely changed the way we write tests. And as part of the change in the test strategy, what we said was, we said no to manual tests. We are not doing manual tests anymore. We have to automate it. And we also said we don't write UI tests anymore. I don't say that completely because just to test the integration with the UI, you still need to write UI tests. But if you want to test a functionality, a lower level functionality, you don't need to write a UI test to test that. You will write a unit test for that, right? So then we said yes to unit tests. And we also did a lot of trainings on the art of unit testing, basically. So there were a lot of myths about unit testing. So some people said, unit testing, it will not work for me. My project is too big. Or, for example, we had a project which generates some documentation. It was generating some kind of a PDF in the end. And they asked us, how do you think I can use unit testing to compare two PDFs? So it was a completely different understanding of unit test. Unit test is not meant to test some two PDFs, but it is meant to test at a lower level. You would test things at a method level, right? So this was one myth that we had. Then we had other myths like unit testing, it's so tedious. My code is legacy. I have been writing this code a long time. Now I have to introduce unit tests into it. It's so much of work or rework, but people didn't realize that the gains are going to come at some time. Yeah. And then somebody said, we have integration tests. Why do we need unit tests again? Because they didn't realize that unit tests are basically the protection layer that you offer for your tool to detect your bugs. That's the first point where you can detect bugs if you have good unit tests. And some people also said, my code is rock solid. I don't need tests. I don't need unit tests. So we all changed it completely by having a lot of sessions, trainings on just concentrating on unit testing. And one important training we conducted was a session, or many sessions, on dependency breaking techniques. Yeah, so these are the techniques which you could easily use when you have such a legacy code or a coupled code. What often we face is that you are not able to call or write a test. Because, for example, you want to instantiate a class from a unit test, and you see that this class, this God class, has so many other dependencies, and you're not able to instantiate them from a unit test, right? Or sometimes the method that you want to test is calling so many static methods, and you can't override this behavior, right? So this is a typical thing that we face while you write unit tests for an existing code, and then you leave the idea of writing unit tests. You say that, okay, it's not going to work, it's too much of refactoring, I will do a manual test. This is where you give up writing unit tests. So if you, as a small advertisement, if you want to know more about dependency breaking techniques, there's another talk I'm giving today evening at 5 o'clock on just 30 minutes on this dependency breaking technique. So it's at the FMS auditorium. It's on the other side of the road as part of Project Quality Day. So if you guys are interested, you can also come in there. The next most important thing that we did, this I really like what we did. Yeah, my colleague agrees with me what we did. This was the change in how we classify our tests. Because traditionally, historically, we have been always categorizing our tests as, you call it either unit tests, or you call it, let's say, integration tests, yeah? And if you follow the theory, you would say a unit test, yes, it should test things at a method level, yeah, at a class level. And what happens if this method is calling other methods? Is it then an integration test, or it's a unit test? Yeah? So this borderline, you don't know whether you want to call it unit test or call it integration test. But we realize that we don't gain anything by giving it a name. Yeah? The purpose of that test is speed. So we just classified our test into 3 categories called fast test, slow test, and slower tests. So the fast test automatically were mostly the unit tests. Yeah? These were running under 1 second. So we had a component which has like 500 tests, which runs in 30 seconds on the server. So it's such a quick feedback that you get. So if you run it as part of your build, or as part of a compile build, you not only get a notification that you didn't cause any compile failure, you also make sure that none of your unit tests are broken. So we just only link those tests which are really fast to this fastest test suite, let's say. And then you have the slow tests category. So the slow test category, because as I told you, we had a lot of UI tests. We can't just say that we are going to rewrite all of them as unit tests. There is always a transition phase you can do it. So you can't just leave your code not covered in that time. So we said we put all these UI tests, what we have, into slow tests. And these slow tests are run only once in a day as part of your nightly build. Yeah, it takes a while, it takes maybe 1 to 2 hours, but it's just run only once. And the plan is that we slowly migrate all of them to more and more faster tests, and we will have less slow tests. And the last category is the slower tests, which are like complete end-to-end integration tests, like you import a complete project and run something. For example, in our case, it was to generate some code out of it, out of these models. So it used to take, a single test case would take sometimes like 1 hour or something like that. And these were the slower tests, and they were run only weekly once as part of the build, right? So these 3 classifications made it so simple for us, ended all debates on shall I write a unit test or an integration test and things like that. Just think about the speed and put them into one of these top-level test suites, and then you're fine. Do you think it's worth this idea? Or have you also faced the problem of categorizing your tests? Yeah, some of you say yes. Yeah. Right, right. So I would say we are still in the process of defining what's the right threshold for it. So one thing was clear for us, that the fast test shall not take more than 1 second. Yeah, and this we tracked. We also developed, we have it on the server, which shows the time of every test is taking. We also developed an Eclipse client where everyone can see the complete test. You can navigate through your test suites and see how much time did it take. And it also shows in the last previous runs how much time it was taking. It shows also a graph of what's the speed. And it's always running on the server, so you can also trust that, yeah, the server is always behaving the same. Yeah. And then we also introduced test competence team. So it was not enough to do some trainings and roll out and say that, okay, you guys now write a unit test. That wouldn't work in that way. So we established a group of people who built up first their own competence about testing, and they were responsible for spreading this know-how of testing in the whole team. And they were acting like consultants. When you have a problem writing a test, please contact them. We also set up wikis. We also set up forums where you can also discuss your problems, and they were always ready to help. Yeah. And then we established something called a test labs again. So much on testing, you see. Yeah, but it was really worth doing all this for testing. The test labs was, again, for us, a store for us in our wiki where we documented everything about testing. So it had so many links. It was like a dashboard for us where you start your activities with testing. It talked about our test strategy. It showed a graph on where we stand with respect to our tests. And all information that you need with respect to your testing was there in the test labs. And all of our experiments with testing, everything, incubation things, everything was put into the test labs. And we also did testing days. This was really cool. We had complete days just talking about testing. We had so many talks. It was like a mini Eclipse Con, so to say, where people were presenting their topics on testing, did hands-on, did test-driven development, and it was really fun days with testing days. And the last one we did was Ozone. This was our test utility store. We called it Ozone because it was, for us, a layer that would protect us from bug radiation. Yeah, so the bugs are coming in, and Ozone is supposed to protect it. And this Ozone store was, once you start writing tests, what you always face is that there is so much of setup that you need to do. Be it unit test, yeah, you also need to do a lot of setup, and everyone starts writing their own setup. And if you put all of them together as utilities, what everyone can benefit, then your turnaround time for writing a test is so less. You can just look into the store what's available for your use case, and then just reuse it. So we had like a marketplace of utilities, custom utilities for our project, which was put into the Ozone test utility store. For example, we work with huge models, like we have EMF models, and most of these models are loaded from XML files, huge XML files which could go into gigabytes. And if you want to write a unit test, you can't expect to load an XML file, create a model out of it, and write some tests on it, right? So you don't want to depend on some file system when you do write unit tests. So we had something like a model builder, which was like really a fluent interface. It was an API, yeah, like the Ruby-like interface where you say create model dot of type dot and. So it was like this builder pattern, and you could really easily, like in simple English, but in Java, right, build your small models, what you could use as input for your tests. And this was one of the main topic that we invested a lot of time to bring out. How can you easily create models when you're working with a model-based tool? Right, and the last thing that we did, as I told you, very important, is that set the limits, to define the limits. So we identified the areas where we need to track and measure continuously, and the first limit that we set was on your test success rate. There were a lot of components, and it was defined also from the management side that you need to have a test success rate which is greater than 99%. 100% is optimal, but at least 99% you should have for your tests. Otherwise, it's not acceptable. And code coverage, you see it's greater than 40%. It's still too low, but we wanted to set a realistic value first. You can't expect a project which has very less tests to suddenly come to a position that you have 100% code coverage. Yeah? So we said, bring your existing code to at least 40% test coverage, but for all the new code that you write, please make sure at least 80% coverage is there. Yeah, 100% is theoretical, it is ambitious. It's good if you have it, but at least 80% for the new code is expected. And I told you we use a Sonar Cube for our static code analysis, and it reports issues like categorize them as blockers, critical, or major, minor, info, things like that. We said we have a lot of issues to fix, but let's concentrate on the blockers and critical and bring them down to 0. And in one release time, we could bring down almost these issues to 0. Sorry, I skipped one slide. And then we said about the red builds. What we said is, if any component breaks 3 times the build consecutively, then you go into a special meeting. It's called a lessons learned meeting. So it's a meeting where you want to find out what went wrong. So it had 2 effects. One is we could find out what was going wrong. The next was people were not so happy that they become answerable, or they are in an odd situation that they have to answer somebody of why something went wrong. So indirectly, there was also an effect that tests became, or builds became more green, and nobody wanted to have a red build consecutively 3 times so that you go into some meeting and become answerable to something. And for our product, we mostly plan 3 release candidates. Yeah, although it was mostly 3 are planned, it used to go up to RC4, RC5, up to RC10 sometimes, until you have a stable release. And in those days, RC1 was just another day. So RC1 is the day where you see code freeze. There has to be a product which is built. But RC1 earlier for us was just another day, and we knew that this is going to be RC3, 4, 5. We will fix it in one of those RCs. Yeah, this was the mindset we had. But we said the one who breaks RC1, and if you don't have a product the next day after your code freeze, you're going into one more lessons learned meeting. And this really had an effect that we started having on the code freeze day. Everything fine, builds were green. And RC2 and RC3, we made it strict, saying that if you want to fix something in RC2 and RC3, you just can't commit your code. You need to get a vote from the product manager. Unless you have a vote, you don't commit anything after the RC1 phase. And again, it became a little bit tough for the people pushing the things in some phase after RC1. And most of the things were fixed in the RC1 phase itself. And now I would like to show you some proofs. I told you a lot of things. Yeah, now we need to have some trust that did it work really for us. So I tried to show you some proofs. I can't show you everything, but I show you some things. But I have to tell you that it was really 1 year of really hard work. There was a lot of people working for it. There were a lot of teams working for it. There was a lot of commitment that we obtained. And in the end, it really brought us success. And I can show you, this is a test graph. And the red lines here means that the test failures. So top means 100% test failure. it's good if you're below, yeah, 0% test failure, everything has passed. And the blue lines are the total number of tests that you have. And if you see this first part, that was, if you see here, this is 1/1/2014. Until then, we had highly unstable tests. They were always failing, 100% failure. The number of tests that got executed was also fluctuating. And this is the point, exactly the point where we started this, or where we really rolled out this strategy. And you can see that it's improved. I don't say that it's still good, because there are still some problems with the testing. It's always failing. It's still sometimes failing, but I have to say that it's not only because of the tests were failed or there was some assertion failure. We have some problems on our integration server that sometimes it times out. So this is an infrastructure thing that we have to address. But that's not the only thing. We still have some tests that are failing, but this is part of it, but they get fixed immediately. And there was a steady increase in the number of tests that we write. And compared to this last year, if you see that the graph just goes up, the blue line just goes up with the number of tests that got executed. So this is one proof about the improvement that we did with respect to our testing. This is a screenshot from our Sonar dashboard. And if you can see here, this shows the success rate of several components. And you can see that most of them are in the range of 98 to 100. This wasn't the case before. We had hardly 40, 30% or much less average test success. And these are the blocker issues. We brought all of them down to 0. Also the critical. Yeah, there are some guys who need to do some work with 2 critical issues, but I hope they will fix it soon. And then you have the code coverage, and which was the goal was 40%, and we got it above 40%. There are some components which does not show the code coverage. I'm not sure about that, why it was not displayed in the screenshot. But generally, all the components we managed to bring it above 40% of 40% test coverage. And what do we plan next? We want to improve our infrastructure. As I told you, we still have some problems with our tests, failing at times because of infrastructure problems. Our current build setup is based on PDE build and some AND scripts. We plan to migrate it to CBI. CBI is the common build infrastructure from Eclipse, which is based on Tycho and Maven. And we have already migrated some projects on a pilot basis to it. So the next year, we are going to completely move to that. And our build time is expected to come down drastically. And our tests should become more stable because of the infrastructure problems. And we also want to increase the limit that we have set for code average, because 40% is still too less. So we need, in a stepwise manner, we will again hike it up so that people write more tests to improve the coverage. And the last thing we want to do is that we want to maintain what we have now. So it's not enough that we say we stop now. It's all good. It will come back to the old days again. So we continuously want to track and maintain what we are doing and re-strategize, change our test strategies with the time, and keep on improving. And that's basically the last step that we have planned to do in the next years. Right. So that was the short steps, what we did to basically rescue a project and bring us some success and say goodbye to Red. Yeah. Thank you. That was it. So, do you have some questions now? Yes. Right. Right. You mean after, so I repeat the question again. The question what the gentleman was asking is how much of effort is going into the testing activities compared to the whole development activities. If you're talking about the earlier situation, it was absolutely 0. There were no testing activities. But now I have to say that I have to admit that I don't have the right measurement at the point. So we have a release coming up now where we really plan to exactly get the exact value what went into the last release. But we, to start with, we said nobody had a clue on how to estimate their efforts. When you suddenly say that, okay, now you need to also write tests. So we said that just blindly make twice the effort. So if you delivered something in 5 days, it's 10 days. Yeah, it's just double the time, because this was the phase where a lot of effort would go in to bring the code, which is not testable, into testing. Over the while, it goes down, but at the moment, I would say we said it's 50-50 for the estimation. When you want to estimate something, just completely the same effort, double the effort. Yeah. Testing days. The last year, we did it once, and this year, we have one planned end of the year. So it's just, with the name testing days, it was only one, because it's a whole day of dedication from everything else to this. But the trainings we do often. Yeah, whenever somebody needs a training, we used to do it often. Yeah, I saw questions in there. Yeah. I'll start with the lady here. Sorry. Okay. Right. The question here is that, do you have a dedicated testing team? I would say no, we don't have a dedicated testing team, because we are talking here, we want to focus more on unit testing, and the guys who can write unit tests are the developers themselves. Sorry? Sorry, I didn't hear that. All the girls. So, sorry, because of the acoustic, I could not really get that. But we were, the developers themselves were writing the automated test, and there was no effort involved later for a testing team to do some tests, so because it was all automated, right? Exactly. So you either write the test, follow test-driven development, that you write the test first and write the code. This was not so easy for the existing code, but the dependency breaking techniques, what I talked about, they're so good, they're so cool, I would say. It made you automatically think, so because now you're doing it at a later stage, you wrote bad code, now you have the pain of writing tests for that, and you use the dependency breaking techniques, and then you learn automatically that, okay, I don't have to use these techniques if I write it properly next time. And this had a lot of effect in improving the quality of the code people started writing newly. And I would really advise you to come to my next talk. It's really cool, the dependency breaking technique. Just walk 5 minutes or 2 minutes across the street. Yeah. Yes. Right. Exactly. Right. Right, that would be really nice. Yeah, I'm not aware of that, but if you have something like that which automatically did it, it's good, because as we said, we have a not so good infrastructure with PDE and our tests, so after we move into Tycho and Maven, you plan to also think about what other tools can help us, but I take your suggestion there. Some more questions? Okay, so I would also ask you if you could all go to the Eclipse Con page, to this talk, and give your vote. That would really help me to come next time, or not to come next time, maybe. Yeah. Thank you.